Hello, this is Harry Does Data. I'm Harry Norton, and welcome back to my series on R programming for beginners. In this session, we're going to be finishing our work on data structures with what are probably the two most important to us as data analysts using R: lists and data frames. Lists allow us to store several different data types, or even several different data structures within one object in R. Data frames are a special version of a list in which all of the objects stored within it must be vectors of equal length. Data frames allow us to store collections of observations such as this, which will be the main data structure we use for doing data analysis in R. So, let's get into it. But before we do, if you found these videos useful so far, please give this one a quick like, it will really help me out, and subscribe to my channel so that you don't miss out on more great data science content. So lists and data frames. So this is where it starts getting a lot more interesting, guys, because now that we've learned the fundamentals of data types and data structures, by the end of this tutorial, you'll be able to start playing around with some real world data sets, and then next time we'll be getting on to things like plotting. So well done for making it this far, and let's get cracking with lists. As I said in the introduction, lists can essentially hold any data type or any data structure even. We define a list object very similarly to all of the other data structures so far. So if we have an object named something like list1, and then we use the list function to define that object. And then we can just pass it a bunch of data. So we could have a numeric piece of data, 12. We could have a character piece of data, such as Harry. And we could have a logical piece of data, true. And if we just run that, then you'll see that it creates the list object up here. And so we have now got a data structure in which all of these three different data types have been stored. And if we just run list1, so run that, then you'll just see how it's represented down here in the global environment. If we look at the output from running list1, then you'll see that each of the numbers in these double brackets represents the index of the item within that list. So the first item, or the index 1 in the list, is the object 12. The second item is Harry, and the third is true. Now, something of note that I haven't mentioned before is these numbers that appear at the start of each line of code in the terminal. So if I do something like a sequence from 10 to 1000, then this will make a lot more sense. So it simply refers to the index of the first number in each line that is represented in the console here. So obviously in the first line, we have index 1. Now when we get down to the second line, what this means is this is the 20th number in this object. This is the 39th, this is the 58th, and so on. So that's just something to bear in mind. That's why the console shows these numbers next to the output. So we have list1, a list containing these three different data types. But a list can also contain any of the data structures that we've already looked at within it. So you could have a vector, a matrix, or an array all contained within a list. So I've just got some predefined objects here, one character, one vector, one matrix, and one array. And we can define a list using these objects. So we could have an object called list2, and we'll assign that using the list function to contain each of these objects above. So we have char, vec, matrix, and array. And I need to make sure to run these so that each of them is actually saved to an object. So we got these objects over here now. And now I can run this list function, and you'll see that list2 is a list of length 4, and it contains all of these things that we just defined. So it has a character, an individual character within it, Harry. It has a character of length 3, so a vector of characters, A, B, and C. It has a matrix of 3 rows and 3 columns, and that has integer data within it, 1 to 9. And it has a array of 3 by 3 by 2, and again that has integer values within it. And all of those are stored within the list. We can also just run list2 down here to see how it's shown in the console. And now what we have is, again, each of these numbers in double brackets represents the index of the item within the list. So the first item is the symbol character value Harry. Then we have the vector of characters ABC. Then we have the matrix of values 1 to 9. And then we have our array. So the fourth item is this entire array, with the first layer being the values 1 to 9, and the second layer being the values 10 to 18. So that's how we might define a list. Now, what if we want to access these individual items that are within the list? So we might do something called member referencing. So each of these indexes, as I said, is a member. So the first member is Harry, the second member is this vector ABC, and so on. So we can reference the list just like we referenced our vectors and our other data structures. So we could do list2, and within these square brackets, we could define which member we want to retrieve. So let's just say we want to retrieve the first member. So we need to put it in the double brackets. So the first member of list2, and if we run that, you'll see that we get the value Harry. We could also, let's just, for instance, do the third member, and then we get returned our matrix. Now, one thing that we can also do is we can actually have lists stored within a list, and this is called nesting. So if we just go back up to list2 up here, and we'll define it as also having within it list1. So from our original list, we will put that within our second list. And if we just run list2, then you'll see that the fifth member of the list is our first list. And here you'll see that you get slightly different indexing. So you have the fifth element of our list 2, and then of that list you have each element. So fifth member element 1, fifth member element 2, and fifth member element 3. And so what if we want to retrieve an individual one of these members? Well, we could do list 2, and within our double brackets we'll specify that we want the fifth member of list 2, and that on its own would return the entire list 1. And then after that, we can treat that as an object itself. So we could add another set of double brackets, and let's say you want the second item. There you go, it just comes back with Harry. So the second item of list 1, which has been stored within list 2, has now been retrieved like this. You could also do something similar, say if we wanted to get the second item of the vector that we've stored within our list. So list 2 has a vector stored as its second element. And let's just say we want the second value from that vector only. So we can run that, and you'll see that we get from the second element of the list, or the second member of the list, which is our vector, we get the second element, which is B. So that's known as member referencing. But what if we want to retrieve, say, several elements from our list? Well, you can use something called slicing. Slicing uses our single brackets and is more like what we did with our other data structures. So if we want the second and fourth elements of list 2, then we just use single brackets here, and we define a vector within with the indexes of the values that we want. So the second and fourth, and if we run that, you'll see that we get the second and fourth values from our list, but now they are returned as a list themselves. So the second member of the original list has become the first member of our new list, and the fourth member of the original list has become the second member of our new list. And just like anything that came before, if you actually want that to be an object itself, then you need to assign it to a new object. So now we have list 3 as the sliced version of list 2, containing only the second and fourth members. Now, to make lives a bit easier for ourselves, so that we don't have to remember the indexes of each of the items within the list, we can also name each of them. So to do this, we would use the names function, and we'll use it on list 2. And on its own, this would just return the names of the list, which are currently set to null. So what we can do is we can assign values to the names ourselves. So to do this, we need to define a vector, and this list is of length 5. So this vector needs to have 5 character values within it to give them the names of each of our members of our list. And I'm simply going to call them by the data structure which they are. So we have a character data type, a vector, a matrix, an array, and a list. And if we run that, and then look at list 2 again, then now you'll see that instead of having member values, each of the members of the list is actually defined by its name. So you have the character, vector, matrix, array, and list. And now what's useful about this is it actually allows us to retrieve these values using member referencing. So I think we used the $sign before in one of our other data structures. And so let's just say we wanted to get the array from our list. We could do list2 $, and then you'll get a list of the options here. So we could pick any of our named values. Let's just go for array. And if we run that, then you'll see that we are only returned the array from our list. And again, you can treat this as an object itself. So let's say we have just the vector from our list. Let's get the vec. Then we can just index and say that we want the third value from that vector. And you'll see it returns C. So that's lists, and a data frame. So that's lists. And we're going to move on to data frames. And data frames are essentially just a special version of a list. And they're the most common way in which we will work with datasets in R. Now, as I think I mentioned in the intro, a data frame is essentially a list with several rules attached to it, but the main one of them is that it only contains vectors of equal length. So I've got a pre-typed out data frame here, and you'll see that the first member within the data frame, first, is a vector containing the first names of 4 people. The second member is again a vector containing the second names of 4 people. The third object is a vector containing the position of those 4 people. The fourth is the age, and the fifth is their salary. And you'll see that this data frame is assigned to the object employee data frame. So if we run that, you'll see that this object is created up here called employee data frame. And if we click on it, you'll see that a data frame takes much more the form of a conventional spreadsheet, where each of these rows is known as a record, and each of the columns is known as a variable. And so we have records for each of these people containing 5 different variables. Now, a lot of the time, when you're working with data frames, you will have imported them from another source, or R has some built-in data frames that we'll look at later. But this is how you would go about creating your own data frame if you wanted to. So something else that you would want to do is to be able to add new data to this data frame. And we can do that in 2 forms. We could add new records, so new rows to the data frame, or we could add new columns or new variables to the data frame. So here I have predefined a new record. So I have an object called new employee, and this itself is a data frame. So if we run that, you'll see that it's a data frame with only one observation of the same 5 variables that we had above. So the first name, second name, position, age, and salary. Now, if we want to add this to the existing data frame, we need to use the function rbind, which we looked at when we were looking at matrices. So we could have the function rbind, and we could just supply it with employee data frame and new employee. And if you run that, you'll see that we're returned a data frame containing the new record for Angela Martin. But if we want to actually save that as an object, then we need to assign it to an object itself. And what we're going to do is we're actually just going to overwrite the original object so that we have an employee data frame containing the new employee. And that is how you would go about adding a new record to your data frame. Now, as I said, we might also want to add data in the second way, which is to add a new variable to our data frame. So here I have a new variable called sex, and it contains the sex of each of the records within our data frame. So this first one would be for Michael Scott, the second one for Jim Halpert, and so on. And if we just define that as an object, then we can use it and go back to our cbind function to bind a new column onto our data frame. So I'm just going to copy this from up here and change that to cbind. And we already have employee data frame, and now we just need to bind sex onto it. And now you'll see if we open up our employee data frame, we have 5 records and we have 6 different variables for each of those records. Great, so now we have a data frame and we can start doing some data manipulation with it. One thing that we might want to do is to extract certain rows and columns from our data frame. And this is very similar to what we did with lists just now. We might want to extract a row or a column by index. So we could have employee data frame. And now we need to supply it with a row and a column value. Or if, say, we just want a row, we could ask for the first row and all of the columns, like this. and you'll see that we get the first record returned to us for Michael Scott and all of the variables for that record. Similarly, we might want all of the records for one of the variables. So if we just have employee data frame again, let's say we want all of the records, so we won't specify a row value, and we want the third variable. You'll see that that provides us with all of the positions for each of the records. And you guessed it, if we want a specific value from the data frame, then we can just apply it with both a row and column index. Now, as you saw, our employee data frame already has named columns, so we can use these to extract data from the data frame. And we do this using the $, just as before. So employee data frame, $, and let's just go for salary. And if we run that, we returned all of the salaries for each of the records within the data frame. And probably the most useful way of extracting data from a data frame is using logical flags. And we did something similar to this in the other data structures. So we're going to use our logical comparisons to decide what data we actually want to extract from the data frame. Let's say we want all of the data, but only for employees over the age of 30. So we would go about that by taking the employee data frame object and using a logical comparison to say employee data frame again. So we want the employee data frame object where the employee data frame age values, so the age values from the employee data frame are greater than 30. And if we run that, then that doesn't work because we have not provided a comma here. So remember, we want all of the rows or records in which the age of the person is greater than 30. So we need to tell it that's what rows we want, but we want all of the variables or columns for that record. So if we run that now, you'll see that we get all of the variables, but only for the employees which have an age greater than 30. And just going back to our logical operations, we could have multiple logical operations in here. So what if we want all of the employees where the age is greater than 30 and they're male? So employee data frame sex is equal to male. And we'll run that. Now you'll see it's taken away the Angela Martin record, so we're just left with the males over 30. And if we only want certain columns, then we could specify here a vector with the columns that we want. So if we just want the first, second, and third columns, then we can do that. So this is how we create and manipulate and extract data from data frames. So now I'm just going to point you in the direction of a few of our built-in data sets, which will allow you to just have a play around and actually start getting to use some data in R. So if we just use the data command and run that, then you'll be provided with a list of data sets that come built into R. So you can see there's quite a few different data sets here. One interesting one I know of is the MT cars database. So to access one of these, we can simply say view MT cars down here in the terminal or the console. And if we run that, then you'll see that this comes out as a data frame. And it has records for several different cars and different variables for them. So their miles per gallon, the number of cylinders, the displacement of their engines. And you can do any of the things that I've shown you in this tutorial with this data set. So for instance, you might simply want to just get one of the columns from the data set. You can directly reference the MT cars data set. So even though it's not an object up here in our global environment, it is an object in the R environment overall. And so you can access it just the same way as an object that is in the global environment. So we could have MT cars, and you see here we get a list of all the different variables. So we just want the horsepower, then you can just get the horsepower. Now, if you like having this object in your global environment, so you can see it up here, then you can just add it to your global environment by creating your own object. You could have an object called MT cars data frame, and you just assign to that MT cars. And now you can see we have the MT cars data frame saved as an object in our global environment. So I recommend you have a play around with some of those different data sets. And next time we'll be taking some of those data sets and looking at how we can use them to plot things in R. So here's a very simple example plot function where we're taking the age of the employees in our employee data frame and the salary and plotting them against each other. And you'll see here, maybe there's some sort of trend of salary increasing with age. And that is where data analysis would really begin. So that's everything for this session. If you found it useful and learned something, then please don't forget to give this video a quick like and subscribe to my channel so you don't miss out on more great data science content.